Now, the last section of 3.6 is just how to name acids. Now, acids we're going to recognize as typically something that has a hydrogen on the front of it. We'll talk more about acids and bases later on in the term, but they have characteristics like they have pH levels less than 7. They taste sour, things like that. So there are two types of acids: binary, meaning they only have two elements in them, hydrogen plus something else, and then what are called oxyacids, hydrogen with a polyatomic ion. So there's a couple different ways to name them. So for naming them, if the anion does not contain hydrogen, we're going to use the prefix hydro and ic acid. So for example, HCl, we're going to name it hydro, and then we're going to use the element root for the element that is sitting on the hydrogen. So our element root was chlor, and then we're going to add ic acid, so hydrochloric acid. For HCN, the CN, this was the cyanide ion. Okay, it's a polyatomic ion, so we're going to use the element root, so cyan. So hydrocyanic acid. And so here our element root is inserted. If we had H2S, again, hydro, and here we have sulfur. Now, the element root is not sulf. Okay, it's actually the entire word of sulfur, sulfuric acid. And that's just a historical way of naming, unfortunately, so we just have to get used to those. So practicing will help us name. Now, names of acids, of course, that don't contain oxygen. So here we have hydrofluoric acid, hydrobromic acid. Look at this one, it's kind of funky, but hydroiodic acid. But if you do have an acid, what we'll find is that the suffix ic will be added to the root name if the anion name ends in ate. So for example, this used to be, if we were to just look at this, hydrogen, and then here is the anion name, which was the nitrate gift basket, the polyatomic. So the gift basket has an ATE ending. So we get rid of ATE and we add ic acid. So this is called nitric acid. If we look up SO4, it's called sulfate ion. But this is the weird part. We don't just take the ate off on this one. Sulfur, the entire root is sulfur, and then we add ic acid. So this is called sulfuric acid. If we looked at this guy, this was the acetate ion in the polyatomic table. So we get rid of ate and we add ic acid. Now, if the suffix ends in ite, then we use OUS with acid. So NO2 was called nitrite in our table. So we drop off the ITE and add OUS acid, nitrous acid. So SO3 was called sulfite ion. So we get rid of the ite and we actually have to add UR because the element root for sulfur is sulfur. And then us acid. ClO2 was called the chlorite ion in our table. So we got rid of ite and added us acid. So here's just some corresponding. So the carbonate ion would be making carbonic acid. We had two H's with the CO3. The ite ion would make an us acid. A hypochlorite ion would make a hypochlorous acid. Okay, so we'd still keep the prefix on, but the ite would be changed to us acid. So those are a little funky. Now, from names, we should be able to write chemical formulas from names. Okay, so sodium hydroxide, write down the symbols for sodium. And hydroxide, there's no element called hydrox, So we know that it has hydrogen and oxygen. It's a polyatomic group, so it's O, it's Santa Claus. Sodium's a +1 from the periodic table, so it wants to lose 1 electron to be like a noble gas. Again, if you don't know that, go back and look at chapter 2 on how to figure out the charges of the ions. And then the OH group has a charge of -1 for the entire gift basket. So we're going to swap, drop, and reduce, so it's NaOH. The next one, potassium carbonate. Potassium is K, and it has a +1 charge. And the carbonate, ATE, means I got to have some oxygens with you. So it's carbon with a certain number of oxygens, which just happens to be 3. And the whole thing has a -2 charge. So when we swap, drop, and reduce, we're going to get K2CO3. And again, we only need one of the CO3 groups, so no parentheses around it. Sulfuric acid, ick, means that it had to be coming from sulfate. So it's the hydrogen with the sulfate group. Sulfate has a charge of -2. Hydrogen has a charge of +1. So when we swap, drop, and reduce, it's going to be H2SO4. Dinitrogen pentoxide. Now this is awesome because whenever you do from a molecular name, you just have to write down the number of atoms that the prefixes tell you. You don't have to get charges to balance. Again, you don't need to get charges to balance for molecular compounds. It says nitrogen, N, you have 2 of them. Oxygen, you have 5 of them. Done. End of story. You don't have to balance any charges at all. Cobalt-3 nitrate. Cobalt is CO, and it says, according to this, it's going to have a +3 charge. Nitrate, we have to know from the polyatomic ions that it's NO3, and the whole thing, gift basket, has a charge of -1. So swap, drop, and reduce, and we're going to get cobalt, and we need 3 of the nitrate groups, so we need to put parentheses around and put the 3 on the outside of the parentheses to get 3 of the nitrate groups. Do not write it like this. Whoops. Let me erase everything here. Do not write it like this. Whoops. Sorry about that. My pen did not get pushed. Do not do the 3 nitrate groups like this, because now you don't have 3 of this polyatomic group. You only have 1 nitrogen and 33 oxygens. That's different than having NO3, NO3, and NO3 with a cobalt. Because right now, if we were to look at cobalt with 3 nitrate groups, there are a total of 3 nitrogens in this baby. There is 1 cobalt, and how many oxygens are in this compound? If you said 9, you're correct, because you have 3, 6, 9. That's different than this guy. This guy has 1 cobalt, 1 nitrogen, and 33 oxygens. So it matters if you have parentheses or not. All right, that's it for this week's lectures then. You will need to practice at naming and writing down formulas. I can guarantee it. It's not going to be very intuitive. And so make sure you're looking at these videos. And I'm also going to give you some additional videos from different colleges on how to name. But practice, practice, practice. They will be on the tests. All right.